Hey Geometry, happy Friday. We are in section 4.4 today. It's going to be very similar looking to section 4.3. So just to kind of review that, the two things that we talked about in section 4.3 were this side, side, side and side angle side. Okay, and so basically what we're dealing with is two triangles, and we're trying to show that those two triangles are congruent. And so rather than doing and making the list of all 6 things like we did over here, all of the sides matching each other, all of the angles matching each other, all we have to do is say that all 3 sides match, or we can say that 2 sides match and the angle that is in between those 2 sides match, and then we don't have to do all 6 things, okay? So doing one of those 2 things, then I can say that the triangles are congruent. I don't have to solve for all 6, okay? So that's kind of similar to what we're doing here, except, sorry, I'm going to make you dizzy, except this one is angle, side, angle, and the other one is angle, angle, side. Okay, so angle, side, angle is illustrated here with these 2 triangles that we have. We are trying to show that those 2 triangles are congruent, same shape, same size, everything. Okay, and so what they've done is they've labeled B and they've labeled E and they've said those 2 things are the same size. Great, that's an angle here. Okay, that angle and that angle match each other. Then they've gone ahead and said this angle here, angle A matches angle D. That's another angle. Okay, and in order to be angle, side, angle, like it says up here, the side has to be the side that is in between the 2 angles. So if I have these two angles right here, the side that has to match has to be this side that's in the middle, and that will give me angle, side, angle, angle, side, angle. Okay. By doing that, or if I'm able to do that, I don't care about the length of this side, the length of this side, the length of, or the size of that angle. Those will have to be the same as this side, this angle, as long as these 3 things match these 3 things. They have to be the same, okay? There's no other way of drawing triangles that have angle, side, angle matching that they don't have these sides and this angle match, okay? So we don't have to do all 6. We only have to do an angle, a side, and an angle, but the side has to be between the 2 angles, okay? So we're going to do that in a proof down here. This is our diagram. This is what we have going on, and we always start with the given, and as we write the given down, we're going to mark anything that we can on this diagram, okay? And then we're going to take inventory over here. Inventory is what we have. We know that we're doing angle, side, angle, so as I list and write down the angle, side, and angle, I'm going to list the inventory over here, okay? So it says, the first thing it says is that QS bisects angle PQR, okay? QS, this side bisects angle PQR. Okay, so that doesn't really give me an angle or a side really, but what I can say from that is that if this guy is bisecting this angle right here, it's splitting it into 2 equal pieces, which means that this angle, let me do a different color, this angle here and this angle here have to be the same. If this guy is bisecting this, these 2 pieces have to be the same, okay? So I'm going to leave a little bit of room to write my second piece of given information, but I am going to, from this, it gives me the fact that this top angle here and this bottom angle here match each other, if that's the bisector, okay? So that top angle, I can't just call it angle Q because there's 2 angle Qs, so I have to name it with 3 letters. Let's call the top angle angle PQS. Ooh, that was really bad. Angle PQS. And he is going to be congruent to the bottom angle, which is angle RQS. Okay, RQS. So from that, we have an angle. Okay, so, and that wasn't the given information. That was a definition of an angle bisector. By definition, it means an angle bisector bisects an angle and splits it into 2 equal pieces. Bisector, not bisectors. Definition of angle bisector. So since this guy splits the angle into 2 equal pieces, I write those 2 equal pieces down. That's by definition what it means to be an angle bisector. Okay, so mark this guy, mark that guy, we have an angle. Perfect. Now we still have another piece of given information, so I'm going to skip back up here to my empty spot, and I'm going to say angle PSQ is congruent to angle RSQ. Okay, PSQ is this angle here, and our SQ is this angle here. I'm going to mark them with 2 markings now, because so that they don't look like they match this guy over here. 1 marking was already used, so we're going to use 2 now. That gave me another angle. Okay, so the given gives me an angle, and then from the other piece of given I'm able to draw an angle. Okay, so inventory. After I'm done with all that, I have 2 angles. Angle 1, angle 2 are crossed off. I just need to find the side that is in between the 2 angles, right? Okay, so actually I'm going to do this. Cover up this bottom triangle, okay, with your hand. Don't cross them out like I am. Cover them up with your bottom hand, okay, with your hand on the bottom. And we need to decide which of these 3 sides is going to be the side that I'm going to pick on. Is it going to be this side, or this side? If it's angle, side, angle, my angle was here and my other angle is here. So the side that I'm going to pick on has to be the side that is in between those 2 angles. It's got to be this guy, okay? This side isn't between those 2 angles, okay? If the angle was up here, it would be, but it's not between the 2 angles yet, okay? So this bottom guy is the side that I'm going to pick on. All right, I'm going to erase all of that and remark my diagram. There he is, there he is, there he is. So I have to pick on this side right here. Oh, wait, but we already know that this side is the same for this triangle and for this triangle because it's the same side. They're like touching each other. So that was like that duh thing, right? SQ is the same side for both triangles. So SQ is the same as SQ. That was that duh. Like, do we really even have to write that down? Yeah, we actually do. That was the reflexive property. Okay, reflexive property. And now we have a side. Okay, now sometimes your inventory will not be like the way that you put them in order will not match the order up here. Okay, but just because our inventory, the order in which the proof goes doesn't match, we always go by the way that it's presented on the diagram. So don't look at this inventory angle side over here to determine what it is, angle angle side. This one, don't look at this order. Don't look at the order of this, okay? This is not an angle side. This was actually angle side angle because according to the diagram is where we find which one it is, okay? This was an angle side and then an angle. The side was actually in between the 2 angles. So don't look at the inventory over here to determine whether it was angle side angle side, that type of thing, okay? Just because we put it in a different order doesn't mean it's not still angle side angle, okay? So ASA, and we're going to say our proof statement was PQS. I'm getting that from this information right here. PQS, that top triangle, is congruent to RQS, the bottom triangle. And now we are done. Okay? All right, the next one here is angle side. And we're going to look at how that is different, okay? So angle side, they start us off with 1 angle here and 1 angle here. That's an angle, okay? And here this angle matches this angle, and that's another angle. So we have 2 angles. If this was angle side angle, the side would be in between the 2 angles. It would be ASA like this, okay? But we don't want angle side angle. We want angle side. So angle, if I'm going like around this direction, this side is the side that I have. So angle side's going kind of in a clockwise rotation. Okay, this one's going in a counterclockwise rotation. It doesn't matter just because these diagrams are flipped. So going in a circular motion, angle, and then my side. Okay, now technically, this would be angle side angle if this side matched this one instead. Right, it would just be going angle side this way and angle side this way, okay? So angle side is just another way of proving that triangles are congruent. We don't have to do all 6 pieces, like all 3 sides, all 3 angles, because the other 3 pieces will follow. This side will automatically be the same as this side. This angle will automatically be the same as this angle. This side will automatically be the same as this side, as long as angle side matches, okay? All right, so let's go down and do this next proof here. And this is kind of messy over here. What I'm going to do is I'm going to draw this in 2 separate pieces because it makes it a little bit easier for me. So this green triangle is ADC, and I'm going to draw him up here. Just do the best you can to redraw these. A and D and C, okay? Then I'm going to do the pink one, which is this guy right here. And that is, it kind of goes this direction. Do the best you can. I know that it's kind of gross. CBE, that's what he looks like, okay? All right, so I'm going to mark them on these two separate diagrams as we go through our given information and everything, okay? So start with your given and write down everything of the given that we can. Angle DAC is going to be congruent to angle BEC. All right, let's mark it over here. DAC is this top angle here, DAC, top angle up there, and BEC is this bottom angle down here, okay? So those two things match each other. So taking inventory, whoop, inventory, I have an angle. Whoop. I have an angle, okay? The next thing says DC. I'm going right here with my other piece of given information. DC is congruent to BC. DC is this bottom side here. He is the same as BC, which is this top side here. All right, so now taking inventory, what does that give us? That gives us a side. So we know we're doing angle, angle, side. So I have an angle and I have a side and I need a third angle, okay? So we have to look at these two diagrams right here and we have to determine which angle we're going to pick on, okay? So really we could say that this angle is the same as this one, right? Or we could say this one is the same as this one, okay? Now which one can I definitively say, given no other information, that they are the same? Well, C better be the same as angle C, right? This angle better be the same as that one, because really in the diagram over here, they overlapped each other. So we have kind of two angle C's, but they're both the same C angle when they're overlapped each other, okay? So that one's kind of be the reflexive property, except it's not two sides that we're saying are equal to each other. We're saying angle C is congruent to angle C. So that was kind of the property for two angles, okay? And we can get away with calling it just angle C, even though it's really kind of two separate angles, because there is no other angle C. If angle C had like another angle up here, we would have to name it with 3 letters, but we can just call it angle C. So that gave us for inventory the other angle, but don't look at the order of this. This is not angle, side, angle. It's actually angle, angle, side, because we're going around in a rotation. Let's go like this way. We hit the angle, then we hit the side last. Okay, so angle, angle, side. The side is not between the two angles like it was up above. So the last thing that we say is angle, angle, side allows me to say that those two triangles from that diagram are congruent to each other. Okay, and that's what that looks like. All right, one more thing, and it's not even really, well, not really a proof, I guess. This little diagram over here has like two little triangles going on with it. I went ahead and drew it over here so that we can see it without the picture, because it's kind of hard to see with all the landscape stuff in the background and everything. But one thing that I want to say is that the river is marked by BC. BC is directly across the river, okay? So I am going to mark him like that. So go ahead and redraw this guy, and then kind of mark BC as like your river, your bridge going across the river. All right, Jeremiah is working on with a community service group to build a bridge across a creek at a local park. So he's building the bridge from B to C. This is where the bridge will be located. Bridge, okay? The bridge will span the creek between points C and B. We just said that. Jeremiah located a fixed point D, which is on dry land. If you look at D over here, D is on dry land, because I don't want to wade the creek. I don't want to walk across the creek. So what I'm going to do is I'm going to pinpoint some stuff on dry land and then use that to kind of measure BC, okay? So used as a reference point so that the segments have the relationship shown. All right, so what we're going to try to do is we're going to try to say, okay, is this triangle the same size or congruent to that triangle? And if they are, we can do some measurements over here and show and figure out how long the bridge is without actually wading the creek, all right? So if these two triangles are the same, then DE up here should be the same as BC, the bottom here. So I can measure this guy on dry land, and then that will give me the length of the creek as long as I have pinpointed those guys and the we've proven that those two triangles are congruent. Okay, so let's talk about some things that allow me to say that those triangles are congruent. Okay, so let's start off with this guy here. We know that this angle right here matches this angle right here. They're both 90 degrees. So angle D has to be the same as angle C. Okay, so that's going to give me an angle. Okay, and I only need to do 3 pieces. So I need to do either a side or an angle or another side, you know, whatever. And I have to have 3 pieces. 1 piece is already done for me. Those 2 angles match each other. Great. Okay, let's go with some other information in here. It says A is the midpoint of CD. CD is this segment right here. And if A is exactly in the middle, then this top part right here better be the same as that bottom part. That's what the midpoint, that's what it means to be the midpoint. So DA is going to be the same as CA. This top segment is going to be the same as that bottom segment because A is the midpoint. Well, that gives me a side. Okay, let me a side. Let me erase some of this stuff over here so I don't get too bogged down with things here. Okay, so that gives me a side. So I'm going to mark him. Let's do it here. I'm going to mark this side and this side. Okay, now I need one other angle or one other side, you know, to give me what I need here. Okay, and the position that these triangles are in kind of somewhat tells me what I'm going to end up using. The thing that I know is that like the triangles are touching at this point A. And if I pick on this angle right here, I look at this angle right here, and those 2 angles have to be the same as each other because they are vertical angles. Vertical angles. So I have angle, and we can't just call it angle A, so let's call it angle DAE, and let's call the bottom one angle CAB. Okay, and that gives me my other angle. So then we have to decide what order these are going in. So it might be angle, side, angle. Maybe it's angle, angle, side. We don't know for sure. Let's look at the diagram. Okay, so here's my angle. Here is my other angle. And the side is in between those 2 angles. So this is, in fact, angle, side, angle. So angle, side, angle, those triangles are congruent. So what I can do is I can measure DE, and I can say that whatever this length is going to be the measurement of across the river. Okay, and it tells me DE is 15 feet. How long does the bridge need to be? This one is also going to be 15 feet. Okay, now we can only say that this guy's 15 feet. Yeah, you can sure guess and say it's probably going to be 15 feet. But what we need to do is we need to set up our triangles so that we can verify that those 2 triangles are the same. So let's say maybe I didn't pinpoint D in the right spot. I pinpointed D up here, okay? Then my 2 triangles would not be congruent, and I would have to fix point D and fix point E to be in the correct position so that this triangle would be exactly the same as that one before I could measure those and say that they both are 15, okay? So this is just kind of, what do they call them, surveyors? Not like a survey that you fill out, but like land surveyors. Sometimes they'll take like their little laser beams and they'll point a laser beam at a hill and say that that hill is 2.4 feet away or 24 feet away, whatever. And so that's kind of how you would set this up and measure it. Yeah, that's one kind of usage for what we're doing here with the congruent triangles, at least, is to measure things when we don't want to wade the river. How about that? Okay, down here in this box, this is just a concept summary of the 4 that we've been talking about. These 2 we did yesterday, these 2 we're doing today, and then they have like an illustration of what each one of them looks like. So for like angle, side, angle, the side is in between the 2 angles, and that type of thing. Okay, homework assignment. You guys can cross off number 1 on practice side. This is practice side. You can cross off number 1, so you only have to do 1 proof. And this proof is going to be similar to one of the other ones that we've already done. I think it was pretty well the first proof. It kind of looked similar to the first proof that we did. Okay. This one again is just which angle, side, angle, or angle, angle, side are you going to use if you are given this information. So using these 2 answers, which one will be number 3 and which one will be number 4? Here's your diagram. You're given this stuff. Does that go along with angle, side, angle, 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 side, that type of thing, okay? And then on the back side, you can skip number 3, okay? So 1 and 2, those proofs are going to look kind of similar to this first one as well. All right, but do your inventory, figure out what you have, what you need, and then you will be good to go. Okay, we'll turn that stuff, these lessons in on Monday, and we'll kind of go over any questions if you have them. And next week's a short week.